Here, we're in the article on page 2 in the Learning Target 16 packet with the aim on top, what feedback loops are found in our climate system. So as we read through the explanation and examples, we're going to make sure that we're following the annotation guide. So my annotation guide, I edit a little bit, right? So it says that we're going to color code and highlight key terms and phrases that describe each type of feedback loop. And I'm color coding the negative feedback loop in this pink color, and I'm color coding what I highlight for the positive feedback loop in this green color. And the reason I'm doing this is because this will help me when I go to do the formative assessment that deals with this topic. And that's going to be formative assessment 6. And we're also going to make an effort to pause after each paragraph to make Google comments as a note to yourself, right? That summarize key details or make any connections, drawing conclusions, or asking questions that I want to go back to later. All right, so we're starting this first part. Negative feedback loops are system processes that cause a decrease in function. All right, so I see decrease in function. I'm going to highlight that in pink, often in an effort to stabilize the system. I'm going to highlight that little part too because that seems important. By the way, this whole section here was from the notes that I took from the PowerPoint right there. Right? Here we go. Positive feedback loops are system processes that cause an overall increase or amplification of a function of a system. So I know whatever's happening, I'm going to make my comment, insert comment, positive loops, positive loops cause function to increase in system. Right, so I know that's worked for me. I'm going to go back and do the same for negative feedback loops cause decrease in function. Goal equals stabilize system. Go. All right. Negative feedback loops result in stability. There we go. That seems super important. I'm gonna go ahead and highlight that again. Most natural systems are in negative feedback loops to maintain stability. All right. I'm just gonna highlight that whole sentence. Typically, natural systems are thrown out of balance due to anthropogenic, human-caused, activities or other unnatural disturbances, resulting in positive feedback loops. So I'm going to highlight unnatural disturbance in green and anthropogenic. Oops. What happened there? Ah. Oh man. There we go. And anthropogenic activities in green. And I'm also going to highlight natural systems thrown out of balance in green because I know that's the result of a positive feedback system or feedback loop. All right, let's look at our first example of negative feedback loops. So as I'm reading the example, I'm going to continue to look for key terms that clue in that this is a negative feedback loop. All right, so example 1, the diagram above shows the human body system in a negative feedback loop. Let's start in the middle. If your body temperature increases, right here, then the cooling mechanisms are activated, causing your body to sweat, okay? So I know sweating is the cooling mechanism, right? That's what our body does to cool us down when we're too hot. This leads to a decrease in body temperature, right? So we're decreasing that function. So you return to your normal body temperature here. The same is true in the opposite direction. So let's look at this side. If your body temperature decreases, okay, we see that happening here, the heating mechanisms are activated, causing your body to shiver. This movement increases your body temperature, bringing it back to normal. Okay, so let's go back and highlight the key terms. Cooling mechanisms are activated, causing your body to sweat. Okay, so I see decrease in body temperature. Return to normal, right? So I know that this is happening in the negative feedback loop in order to make the body system return back to normal or maintain stability, right? And it's true in either direction. The temperature, heating mechanisms causing your body to shiver. This movement increases body temperature, bringing it back to normal. I'm just gonna take that highlight out. All right, let's go to the second example. Example 2. There we go. Like the human body system, Earth's climate system is naturally in negative feedback loop. Consider what we learned about how solar radiation, sunlight, interacts with the Earth. Right here, when solar radiation is absorbed, the ocean heats up. This causes the water to be evaporated into the air, where water vapor condenses into clouds. Clouds have a higher albedo than water, so more solar radiation is reflected, causing temperature to decrease back to normal. Okay, I'm going to highlight causing this to decrease back to normal. Okay, so we see here more radiation is absorbed due to temperature increases, water is being evaporated, clouds increase albedo, more solar radiation is reflected, decreasing the temperature. So let's see what happens with the opposite side. The same is true for the opposite direction. If temperatures drop here, where less solar radiation is being absorbed, then the existing clouds will precipitate right here, right? Rain, snow. If temperatures drop, then the existing clouds precipitate, and this decreases albedo and allows more solar radiation to be absorbed, therefore increasing the temperature, going back to normal. So it looks like maintained is a key word for a negative feedback loop. So in both examples, when temperatures are too hot and too cold, we see both situations resulting in this back to normal, or the regular temperature is maintained, right? So those are keywords there. All right, so let's go to positive feedback loops. We're on the bottom of page 3. Example 3, let's start at the top of the diagram. Higher levels of CO2 cause temperatures to increase. All right, so I'm seeing higher levels of CO2. Remember, feedback loop for positive is in green, can cause temperatures to increase. So what's increasing here? Temperature. Higher temperatures lead to faster decomposition, right? So there's something else that's being augmented. Remember, decomposition is a carbon source. Faster decomposition, I'm going to put that because it seems like something's being amplified, boosts the rate at which CO2 is added to the atmosphere. Right, so this rate is being raised. More CO2 in the atmosphere. All right, I'm highlighting that more because I know that I'm associating amplifications and increasing functions in the system are usually associated with positive feedback system or loops. So this results in, again, higher temperatures. Notice that the original effect of climate change was amplified. What does it mean by the original effect? Well, the higher levels of CO2 and the higher temperatures. So this leads to higher temperature, leads to faster decomposition, leads to more CO2 in the atmosphere, which goes back and repeats the same thing. It's just going to keep getting higher and higher. Even higher. There we go. So I noticed that nowhere in here is stability mentioned. So here I'm going to put no stability, just amplified functions in this system. Okay. Last positive feedback loop. On what page is this? 4. So I'm going to make this actually a little bit smaller. Okay. Example 4. Higher levels of greenhouse gases increase Earth's temperatures. Okay, and we already saw that with the last example too. Greenhouse gases like CO2, right, tend to increase the Earth's temperature, as you guys learned with the greenhouse effect. So I'm going to also make that note. Enhanced greenhouse effects can be caused by humans and higher CO2 emissions. Sorry, you can't really see that. Into atmosphere. Okay, and that's just a connection I made to learning target 15 a couple weeks ago. All right, I have my comment done. Second sentence. Rising temperatures can cause frozen soil, called permafrost, to thaw. Okay, that makes sense. That kind of sounds like glaciers melting too, right? And I know that's connected to climate change. The thawing of this permafrost exposes ancient organic matter and they start to decay. Okay, so I see that's right happening here. And as organic matter starts to decay, they release more greenhouse gases into the atmosphere, causing temperatures to increase even more. Right, again, I see no stability here, but I am going to go back and highlight the key terms that helped me realize, oh, this is definitely a positive feedback loop. So I see higher levels increase the temperature, right? So that's a cause and effect. Everything is causing each other to go higher. Rising temperatures cause this to happen. The thawing exposes this matter. As organic matter starts to decay, they release more gases into the atmosphere, causing temperatures to increase even more, right? They don't go back to normal like they did with this negative feedback loop, right? Okay, so now that we've gone through these 4 examples, what you're going to do is you're going to go to your formative assignment 6, feedback loops. Again, that's due Tuesday. And you're going to have to read through each scenario, and you're going to have to identify whether the scenarios given are positive or negative feedback loops. I would suggest also using this similar annotation guide to help you determine whether or not the scenarios are negative feedback loops and positive feedback loops.